Okay, so this is problem 10.3.31, and you can't really read that, but I'll read it to you. Here's the important information here. It says, in a certain city there are 4 streets going north-south and 8 streets that run east-west. How many street paths start at the southwest corner of the city and end at the northeast corner of the city and have the shortest possible length? Okay, so this is a counting problem. And I think, one of the easiest ways to think about this is to give ourselves just a little picture here. So if you think about it, you have 4 streets running north-south. So let's just assume this is north, this is south, this is west, and this is east. And then we have 8 streets running east-west. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and what we want to do is we want to go from the southwest corner, which is right here, up to the northeast corner in the shortest path possible. Okay, so there's going to be multiple paths that are going to be the shortest path possible. But the easiest way to look at it is to just do it via the grid straight lines. Okay, and then we'll think about what that means in terms of the other possibilities. So if I want to go from here to here along streets, the shortest way, one of the shortest ways, is to go here first. So I would have to move 1, 2, 3 blocks east. And then I would have to move from here, I would have to move 1, 2, 3, 4, 5, 6, and 7 blocks north. Okay, so whatever combinations can happen here for moving 3 blocks east and 7 blocks north is going to be, the shortest possible length. Now, there's going to be a bunch of them because you could go, this way, for instance, and you can go up and then over and then up. I mean, there's just a bunch. So we can't count all of those. We can't count all of those by hand. So really what we need to do is I'm going to equate this to something else. Really what we're looking at is something like having a 10 letter word, and 3 of the letters are, let's just let this be E right here, and 7 of the letters are N. Okay, so really what we're looking at is 10 total, and if we count one of them, if we take the combination of 10 things taken 3 at a time, that's going to take into account both of these situations of moving. Okay, so that's taking into account moving here, and then the rest of it is there's no other choice but to go up, so that's sort of already counted. So if we just count the number of ways out of 10 options that we can move 3 blocks east, then the other 7 blocks north will have already be taken into account because they'll be counted in the midst of it. I guess that's the way for me to talk about it. So just for instance, if I was to do this path right here, go here and then here and then here and then here and then here, I have 10 movements. And if I just take a look at the combination of, those 10 movements taken 3 at a time, I've taken into account those. These other movements will be taken into account because that's the only way I can get there, the only way I can go north-south and use these 3 east-west roads. Okay, so a combination of 10 things taken 3 at a time will be the answer here. If we simplify this, this is going to be 10 factorial over 3 factorial times 10 minus 3 factorial. And so that is 10 factorial over 3 factorial times 7 factorial. And I'm going to move that over here. That's equal to 10 times 9 times 8 times 7 factorial over 3 times 2 times 1 times 7 factorial. The 7 factorials will cancel, and this right here, 720 divided by 6, you'll end up with 120. Okay, so your answer there would be 120 different ways that you could do the shortest possible length.